Hello friends, now I am going to start next topic of class 12, chapter 11, alcohol phenol ether, that is reaction in alcohol. In earlier videos we have discussed about reaction or cleavage of RO bond or CX bond in alcohol. Now I am going to discuss the reaction in phenol. The reaction of phenol. First topic that I am going to discuss here is nitration. Nitration means the introduction of nitro group in phenol. We know that in phenol the hydroxyl group activates the benzene ring. This hydroxyl group, which is attached to the phenol, activates the benzene ring and makes it electrophilic in nature. Therefore, it is electrophilic in nature, and most of the reactions occur at ortho and para position because the hydroxyl group, which is attached to the phenol, it activates the benzene ring at ortho and para position. This is ortho position, meta and para. Then the hydroxyl group, which is attached to phenol, activates the benzene ring at ortho and para position. It means that the reaction or electrophile attached to these positions only. Now first topic that I am going to discuss, or first point in reaction of phenol is nitration. Nitration means introduction of NO2 or nitro group. So let's see how we discuss this. This is phenol having hydroxyl group. When it is attached with dilute nitric acid HNO3, then monosubstituted product is formed at ortho and para position. Then nitro group is attached to ortho and para position. This is ortho position. This is ortho position, so nitro group is attached to here and para position. So what we see that in nitration, when phenol is treated with dilute nitric acid, then ortho nitrophenol and para nitrophenol is formed. Ortho nitrophenol is found in minor quantity, whereas para nitrophenol is major. These two products is formed when phenol is treated with dilute nitric acid. And why it is not formed in meta position? Because the electron density is greater in ortho and para position only. Therefore, the hydroxyl group, which is attached to phenol, activates the benzene rings at ortho and para position only. Therefore, the monosubstituted product which is formed is at ortho and para position. These two products are separable also. They are steam volatile in nature. They can be separated out. How? Because the ortho nitrophenol is steam volatile in nature. Ortho nitrophenol, which is formed, is steam volatile in nature, and therefore it can be evaporated, and the container is left with only para nitrophenol. Therefore, these two compounds can be separated out. Why it is steam volatile in nature? Because ortho nitrophenol. Why it is steam volatile in nature? Because due to intramolecular H bonding. What we see, this is ortho nitrophenol, NO2. This is ortho nitrophenol. Now let's see steam volatile nature of phenol. This is steam volatile. How? Because due to the intramolecular H bonding. How intramolecular H bonding is formed? This O get formed H bonding with this H, which is attached in the same phenol. द H ऑफ हाइड्रोक्साइल ग्रुप, जो ये H है वो नाइट्रो के ऑक्सीजन से H बॉन्डिंग फॉर्म कर लेगा एंड दिस इज व्हाट इंट्रा मॉलिक्यूलर H बॉन्डिंग, और ये होती है हमारी इंट्रा मॉलिक्यूलर H बॉन्डिंग. Therefore it is steam volatile in nature. Now therefore due to this intramolecular H bonding, it is steam volatile in nature and it can be evaporated out. Therefore the container is left with paranitrophenol and these can be separated out. Okay, understood? Now let's see when phenol is treated with concentrated nitric acid. In this case, phenol is treated with dilute nitric acid, so only monosubstituted product is formed, that is orthonitrophenol and paranitrophenol. Or when phenol is treated with concentrated nitric acid, so trisubstituted product is formed. Now let's see how this has happened. Now when phenol is treated with concentrated नाइट्रिक एसिड, जब फिनॉल कंसनट्रेटेड नाइट्रिक एसिड से ट्रीट होता है, सो व्हाट विल सी ट्राई सब्सटीट्यूटेड प्रोडक्ट इज फॉर्म. ट्राई सब्सटीट्यूटेड मतलब 3 पोजीशन पे, ये तो OH ऐसे ही रहेगा 2,4,6, दिस इज 2 position, 4 position and 6. So what will be formed? 2,4,6 trinitrophenol is formed. It is also known as picric acid. What we call picric acid. So when phenol is treated with concentrated nitric acid, the tri-substituted product is formed, that is 2,4,6 trinitrophenol, and which is known as picric acid. But the reaction yield is, जो yield होती है reaction की, means the picric acid which is formed is of poor quality, means not much amount of picric acid is formed. The reaction yield is very poor. So how we can yield maximum? So here we see that picric acid is of poor yield. So how maximum yield of picric acid can be obtained? So when phenol is treated with dilute sulfuric acid, 2,4 disulfonic acid is formed, and when again further reaction is carried out by concentrated nitric acid, then a picric acid formed, that is 2,4,6 trinitrophenol. So this is of maximum yield. Now let's see, when phenol, for maximum yield, when phenol is treated with sulfuric acid, then 2,4 disulfonic acid is formed. 2,4 disulfonic acid is formed, and when again it is treated with concentrated nitric acid HNO3, then again a picric acid is formed. What is picric acid? 2,4,6 trinitrophenol. It is formed, picric acid, which is of maximum yield, having maximum yield. Understood? So this is about nitration. Now let's see about halogenation or introduction of halide in phenol. Now the second topic that we are going to discuss is halogenation. Halogenation means introduction of halide in phenol. This is phenol. Now you are familiar with phenol, benzene having hydroxyl group. When phenol is treated with bromine in CS2 condition, in the presence of CS2 which is non-polar in nature, then a monosubstituted product is formed. Then what happened? Monosubstituted product is formed. Bromine is attached at ortho position and it attached at para. So what we seen, ortho-bromo-phenol and para-bromo-phenol. This is major product and this is minor. So halogenation in phenol is when the reaction of phenol is carried in the presence of bromine in CH2 in the presence of CH2. CH2 is what? Non-polar in nature. Therefore, it reduces its activity of hydroxyl group and make it less active. Therefore, only monosubstituted product is formed. What do you mean a monosubstitute? Means single, at only single position it is formed. If only bromine is added, if bromine is added in aqueous medium, then a tri-substituted product is formed. That is 2,4,6 tribromophenol. 2,4,6 tribromophenol is formed when bromine is treated with aqueous medium. So tri-substituted product is formed, that is 2,4,6 tribromophenol. Okay, this is all about halogenation. You know that when halogenation halogenation benzene ring take place, then catalysts such as aluminium chloride, ferric bromide, these are added. But here there is no such type of catalyst. Why? Because it is highly activating in nature, and therefore it activates benzene ring to form tri-substituted product, and there is no need of such a catalyst. Understood? This is all about halogenation in phenol. Now third point is KOLBE'S reaction. What is KOLBE'S reaction and how it is done? KOLBE'S reaction is mainly used for the preparation of salicylic acid. Salicylic acid we have done earlier, the acetylation reaction. Here we have used salicylic acid. And now we are going to see the preparation of salicylic acid. And the preparation of salicylic acid, the reaction which is done is KOLBE'S reaction. When phenol is treated with sodium hydroxide, then a sodium phenoxide is formed, which is introduced. Sodium phenoxide is formed. When sodium phenoxide is treated with first carbon dioxide and H positive, then a salicylic acid is formed. What will form? Salicylic acid. Salicylic acid will be formed. This is KOLBE'S reaction, which is mainly used for the preparation of salicylic acid. So sir, how salicylic acid is prepared? When phenol is treated with sodium hydroxide for the preparation of sodium phenoxide, and when again further reaction of sodium phenoxide is carried by CO2 positive or H positive, then a salicylic acid is prepared. This is about the preparation of salicylic acid. Now the fourth one reaction in phenol is Reimer-TIEMAN reaction. Reimer-TIEMAN reaction. This Reimer-TIEMAN reaction is mainly used for the preparation of salicylic aldehyde. Reimer-TIEMAN reaction is mainly used for the preparation of salicylic aldehyde. So let's see, when phenol, here we have seen KOLBE'S reaction and now Reimer-TIEMAN reaction. These two reactions are somewhat similar. In KOLBE'S reaction we take sodium hydroxide, but as now I am giving you a trick that this name is very big. Reimer-TIEMAN reaction is very big as Kolbe's reaction. Therefore, along with sodium hydroxide here, chloroform is also added. So you may remember that when sodium hydroxide and chloroform is treated with phenol, then an intermediate is formed. That is ONA and CHCl2. This intermediate is formed. What do you mean intermediate is formed? Means the product which is formed during the course of reaction. So when phenol is treated with sodium hydroxide along with chloroform, this intermediate is formed, and when it is further treated with sodium hydroxide, NaCl, and in the presence of acid, then salicylic aldehyde is formed, CHO and OH. This is what salicylic aldehyde. Okay, this is salicylic aldehyde. So there are many products which are formed in the reaction, but you have to write only the reagent which is used for the preparation of this salicylic aldehyde. You can simply write in numbers, and the reaction could not exceed, and terminate at only fewer steps. Okay, so first is Kolbe's reaction. First we have discussed what nitration, when dilute nitric acid or when concentrated nitric acid is treated with phenol. The second one we have discussed is halogenation reaction. Then when bromine is treated with in the presence of CH2, and when it is treated with in aqueous, the tri-substituted product is formed. The third reaction which we deal is Kolbe's reaction. Kolbe's reaction mainly used होता है हमारी salicylic acid की preparation के लिए. तो जब phenol sodium hydroxide से treat होगा तो sodium phenoxide form होगा, जो कि हमने earlier वीडियो से पढ़ चुके हैं. When sodium phenoxide is treated with carbon dioxide H positive, then we get our major product, that is salicylic acid. The same family reaction is this Reimer-TIEMAN reaction, which is mainly used for the preparation of salicylic aldehyde. So when phenol is treated with sodium hydroxide or chloroform, the intermediate which is formed is again treated with sodium hydroxide, NaCl, and in the presence of catalyst or acid, then we get salicylic aldehyde. So these two reactions are completed. First is Kolbe's and the second one is Reimer-TIEMAN reaction. Now I am going to discuss about when phenol is treated with zinc dust or the oxidation of phenol. Now the fifth one is reaction or when phenol is treated with zinc dust. So what will be formed? This is phenol. When phenol is treated with zinc dust, then benzene is formed. What will be formed? Benzene is formed along with zinc oxide. So this reaction is mainly used for the preparation of benzene ring. ये हमारा reaction जो है simply benzene ring के preparation के लिए use होता है. That when it is treated with zinc dust, so zinc oxide will formed as a byproduct and the major product is benzene. Now the sixth one is oxidation of phenol. Oxidation of phenol means when phenol is oxidized. जब phenol हमारा oxidize हो जाएगा or it is treated with Na2Cr2O7 in the presence of sulfuric acid, then oxidation of phenol take place and benzoquinone is formed. What will be formed? This is benzoquinone. Benzoquinone is formed. This is the oxidation of phenol. When phenol is treated with Na2Cr2O7 or in the presence of sulfuric acid, then benzoquinone is formed. These two arrows and here it is attached with both side oxygen. So this is simpler structure you can remember, and this is what This is what? Benzoquinone. So this is all about the reaction. So this is all about the reaction in phenol of phenol. First, nitration, halogenation, KOLBE'S reaction, Reimer-TIEMAN reaction, reaction with zinc dust, and the oxidation. This is all about reaction taking place with phenol. So this is completed all about reactions. Now in our next video, I am going to discuss about formation of ether. You can see or watch that video. Okay, thank you.